This is Advanced Math 10.6 homework questions. That is Advanced Math Unit 10, Lesson 6 homework questions. I'm just going to go over a few from the front page and a few from the back page, and then we'll be done. Okay, I'm going to do numbers 1, 2, and 7, 8, 9. So I'm doing a lot of them with you on the front page. Number 1. Y equals, or f of x equals, that is up to you. If you remember the rules from the notes from Friday, the last Friday we were in class last week, had the steps here. So these are the steps you're going to be following. Needs to be an equation, y equals, take care of vertical asymptotes. I have 2 of them, -2, so that's x plus 2. And a +3, so that's x -3. And remember, vertical asymptotes are always on the denominator. All right, take care of any x-intercepts, which is always the numerator. X-intercepts, there is 1, and it's +1, and it's a cross, so it's an odd multiplicity, so it is x -1. And these here go opposite direction, so these also have a multiplicity of 1. And let's see what else. Oh, take care of any holes. There's no holes, I don't have to worry about that. If there is a horizontal, then take care of that. Horizontal is 0. Can you see that? You can't really see it, but you can tell that the lines are approaching it, so you can tell that it's there. If it's 0, that means it's bottom heavy, and this is indeed bottom heavy. Degree at the bottom is 2, degree at the top is 1. So that is it. Oh, and you check your y-intercept by plugging in 0. You get -1 at the top, 2 times -3 at the bottom, and I'm getting that by plugging 0 in. 0 minus 1, 0 plus 2, 0 minus 3. And that gives me +1/6, which is indeed my y-intercept. Again, that's just a double checker. Okay, that's number 1. I'm going to jump on to number 2. Y equals asymptotes 2 and 4, and they're going opposite direction, opposite direction. Can you see those 2 arrows and those 2 arrows? So the multiplicity is 1. X minus 2, x minus 4, and there's no holes. X-intercepts, there's 1 at 0, and it is a bounce, so it's a multiplicity of 2, and so x minus 0 is just x, and a squared because of the bounce. And what else? Horizontal. The horizontal is not 0, it's 3, which means that it is not bottom heavy. It's the same degree, and it sure is. It's squared at the bottom, squared at the top, which means it's the same. Leading coefficient right now is 1. I need the leading coefficient to be 3, so I put a 3 there, and then we are good. I'll check the y-intercept. Y equals 0, square root of 0 times 3 is 0, over -2 times -4. 0 over 8 is just going to be 0, which indeed is my y-intercept. Okay, I do want to talk about 7 because it is a little tricky. A lot of kids mess up on that one. Y equals, okay, no asymptotes, no vertical asymptotes, no hole. There is a hole. The hole is at -2, so I'm going to put x plus 2 top and bottom. Now, why do I put that top and bottom? Because that's what I'm going to eventually reduce. Well, I'm not going to reduce to my answer, but if I were graphing, I would reduce that, making the hole. Okay, that's it. X-intercepts 1, so I'm going to put x minus 1. And there's no horizontal asymptote, nothing else. This is the answer. I'm going to check the y-intercept. Y equals, let's see, 0 plus 2 is 2. 0 minus 1 is -1. 0 plus 2 is 2. And that ends up being -1, which is indeed the y-intercept. Okay, so how does that work? Let's talk about if I were to have given you this on the test. When you will have something like this on the test, where you're asked to graph y equals x plus 2 x minus 1 over x plus 2. So this is the answer we came up with. But what if I gave you this and asked you to graph it? D, va, ha, sa, x-intercept, y-intercept. We're going to go through that quickly. Domain, all real such that x cannot equal -2. Reduce it, leaving me with y equals x minus 1. And I believe I've said this before, if there's no variable in the numerator, all of your asymptotes are none. You will need to know that for the test as well. None, none, and none, because there's no variable in the denominator. X-intercept, I set the equation equal to 0. Solve, I get x equals 1. Y-intercept, I plug in 0, and I get -1. And then if I were to graph this, intercept at 1, intercept at -1, and the x-intercept is across, where is that, because of multiplicity, and I connect those two. Open circle at wherever I reduced, -2. So I have an open circle at -2 because x cannot equal -2. So I go left 2 to my graph, put an open circle, and there is my graph. And that is indeed the graph, the picture they gave us. So you see how that works? You will need to be able to work backwards like this, as well as if I give you something like this, come up with the graph. Okay, moving on. Number 8, y equals, I have an asymptote here at 3, x minus 3, and it is to the first power because they're opposite direction. You don't have to write the first power there, just know that it is the first power. And x-intercepts, I have one at -4, +2, and they are both crosses. X plus 4, x minus 2. And because they are crosses, the multiplicity is 1 on each one. This is opposite direction, so that multiplicity is 1. I don't have a horizontal, I have a slant, which means it's top heavy, and indeed it is top heavy. X squared at the top, x at the bottom. You don't have to check the slant. If you're like me, you most likely will. I mean, I went ahead and checked it. I double distributed. I did long division. And when I did it, I ended up with y equals x plus 5. I'm not going to show you here, but if you did your long division and you did your x squared plus 2x minus 8 divided by x minus 3, and you did all your work, you'd end up with x plus 5. And that is the line right here, x plus 5. 5 and then a slope of 1, and you get that dotted line. So it does work. You don't have to check it. That was just what if I did want to. It does work. Okay, y-intercept, that you do have to check. Y-intercept, you get, plug in 0. Y equals 4 times -2 over -3, which is -8 over -3. They reduce. It's getting kind of messy. And I end up with 8/3, which is indeed the y-intercept. We are good. Okay, and lastly, number 9, y equals, okay, I have 2 asymptotes. It's kind of hard to see the second one, but it's right here at the 0, at x equals 0, which is the y-axis. It's there. You can tell that little parabola-looking shape is getting squished between 2 lines. It's kind of hard to see, but it is there. Okay, so at the bottom, I'm going to have x plus 1 and x minus 0, which is just x. And they both have a multiplicity of 1 because they're going opposite directions. You see this line right here, those 2 arrows are going opposite. With this dotted line right here, that bottom arrow, that top arrow are going opposite directions. So they both have a power of 1. X-intercepts, I have 2. They're both crosses, so x minus 2, x minus 3. No holes. I have a horizontal at -2, which means the degree should be the same top and bottom. Squared, squared, it is. My leading coefficient needs to be -2, so I'm going to put a -2 right in the front. And that is my answer. And I do check the y-intercept. Y equals -2, 0 minus 2 is -2, 0 minus 3 is negative 3 over 0 times 1. I get anything over 0 is going to be undefined, which means there is no y-intercept. There's none, which makes sense. In the graph, there are no y-intercepts. Okay, so that's for the front part of this worksheet. There is a back side of this worksheet that you were supposed to do as well. So I'm going to flip on over to the back and go over some of those questions here. And this is too much to show on this piece of paper, so I'm going to do them on a separate piece of paper. Starting off with number 2. I'm going to do all of 2A, B, and C. 2A, find the vertical, horizontal, and slant asymptote. F of x equals x squared minus 9 over x plus 3. Notice they did not ask for the domain, just the va, ha, and the sa. Okay, so I factor x plus 3, x minus 3 over x plus 3. I find domain first and then reduce. They didn't ask for the domain, so I'm just going to go straight to reducing, leaving x minus 3. That's it. No variable in the denominator, and I've said before, if there's no variable in the denominator, everything is none. None, none, and none. That's it. That easy. 2b, f of x equals x plus 8 over 6 and taking a look at that one, there's no simplifying to do, there's no reducing, but there's only a 6 at the bottom. There's no variable at the bottom, so once again, your va, your ha, and your sa are all none. None, none, and none. When there's no variable at the bottom, they're all none. Okay, 2c, f of x equals 2 over x plus 3. You do need to have it as a single fraction, so I'm going to rewrite it with a common denominator. I'm going to multiply the 3 by x over x so that I could have a common denominator, because x over x is 1. That's a multiplicative identity. That gives me 3x over x, not over 3. 3x over x, which they now have a common denominator, so 2 plus 3x over x is what I am working with. Va, ha, sa, there's nothing to factor and reduce. Vertical, x equals 0. Horizontal, is it top heavy, bottom heavy, or the same? It's the same, so I take the leading coefficients, which is 3 over 1, so y equals 3 over 1. Y equals 3. And slant, none. Remember, one of these is always going to be, at least one of these is always going to be none. Sometimes all three are none. But when you actually have asymptotes, you're never going to have a horizontal slant at the same time. Slant only if it's top heavy, which this is not, and that's why the horizontal is 3. Y equals 3. Okay, that's it for number 2. I am going to jump to number 3D. Number 3D is asking us to graph. And again, I am on the back of worksheet 6. Worksheet 6 had a front and a back. They were all combined in one worksheet. So right now I'm just continuing with worksheet 6. Number 3D. Okay, f of x equals the quantity of x minus 2 squared over x plus 1 squared times x minus 3. Okay, and we are doing the same thing that we've been doing in class. I'm just making sure I wrote it down correctly. Okay, d, ba, ha, sa, x-intercept, y-intercept. Okay, domain, all real such that x cannot equal -1 and +3. There's nothing to reduce. Vertical asymptote, -1, which is even because of the multiplicity. X equals +3, which is odd because of the multiplicity. I'm just gonna, I usually don't write even and odd there, so I'll do it the way I usually do. M is 2 and M is 1. Horizontal asymptote, the limit as x approaches infinity. It's bottom heavy because it's 2 at the top, 3 at the bottom. Bottom heavy means y is 0, which means the slant is none. The slant only happens when it's top heavy, which this is not. X-intercepts, you set the equation equal to 0. The bottom is not gonna, it's gonna cancel out. It's not gonna equal 0. You get positive 2 with the multiplicity of 2, so it's a bounce. 2 bounce. And y-intercept, you plug in 0. Y equals negative 0 minus 2 is negative 2 squared is 4. 0 plus 1 squared is 1 times negative 3, negative 4/3. All right. And because my horizontal is at 0, I will have to do test values, unfortunately. Okay, so I have a vertical at negative 1. And that negative 1 has a multiplicity of 2, so it is even, which means it's going to go in the same direction. I have 1 at x equals 3. And that x equals 3 had a multiplicity of 1, which means it is odd, going in the opposite direction. I have an x-intercept at 2, that's a bounce, and a y-intercept at negative 4/3, and a horizontal at y equals 0, which means a test value. Okay, how do we do this? So far left, 0, negative 1. So I pick a value to the left of negative 1. I'm going to pick negative 2. You can try negative 5. Negative 2 minus 2 squared is going to be a positive. Negative 2 plus 1 squared is going to be a positive. Negative 2 minus 3 is a negative. Positive over a negative is going to equal a negative, which means I'm all on the bottom. It's either all at the top or all at the bottom, and since I got a negative with my test value, it's all at the bottom. Even means same direction, so I'm starting from down here. I'm going to hit that y-intercept, hit that x-intercept, and it is a bounce. I'm going to come back down. So I'm going to come up, bounce, come back down. And then odd is opposite direction, so I'm going to be coming from the top, approaching the asymptotes like so. Okay, moving on, I am going to do one from the worksheet, from the review section. Let's see, we'll do some from number 4. Okay, write the equation of this graph. Y equals vertical asymptotes, there's none. Holes, I have one at positive 2, so I'm going to put x minus 2 at the top, x minus 2 at the bottom. And x-intercepts, there's a 0, so I'm going to put an x. I'm going to squeeze it out in the front. And because it's a bounce, it is a squared. And that is it. Check your y-intercept, plug in 0. You get 0 over negative 2, which is 0, and that is your y-intercept. Remembering, if I asked you to graph this, you would find your domain, then you would reduce it. And when you reduce it, you'd get that, which means your va, your ha, and your saw would all be none, because we just went over that on the previous problems. If there's no x at the bottom, it's 1. And if I did ask you to graph this, don't reduce it now because it's part of your answer. But if you were graphing it, you would reduce that, leaving you with x squared, none, 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 which is just a parabola with the hole at x equals 2, and there's the hole. Okay, last one I'm going to do with you on this worksheet is letter C, y equals. Okay, I have two asymptotes, x plus 2 and x minus 3. Is that right? And it is, right? But I put them in the wrong spot. Sorry. Starting over. X plus 2 and x minus 3, and they both have a multiplicity of 1 because it's opposite direction, opposite direction. X-intercepts, I have one at -1 and +2. So x plus 1, x minus 2. Minus 2 for that +2, plus 1 for that -1. They're both crosses, so they have a multiplicity of 1. Horizontal is 1, which means my leading coefficient needs to be 1. Right now it's already 1. You don't have to put a 1 there, but I'm putting it there to show you that if it was like a 2 or a 3, I would definitely put it there. Since it's 1, it's not necessary, but I'm just going to leave it. Check your y-intercept. 1 times 1 times -2. 0 plus 2 is 2. 0 minus 3 is -3. That gives me -2 over -6, which is +1/3, which looks about right. They didn't label it, but that looks like it could be +1/3. Check. This is the answer. All right, that is it for these homework questions.